Welcome back, everybody. Hey, shout out sixth period. Shout out. Sorry I can't be with you today, but hopefully everybody's doing all right. Hopefully everybody had a good weekend. Anybody from first period want to say anything to sixth period?
What about Button? I'm still hitting up that 2-man.
Wow, that was embarrassing. That was Devin Moore, if anybody wanted.
Nah, he knows.
He knows. Oh,
People know.
right. All right. So again, if you are in sixth period, you should be pausing the video right now. Mr. Kazenheiser is hopefully with you guys, and he can pause the video. I want you to do this warm up. Remember that the keys are in the binders. Don't forget to put the keys in the binders, everybody, first period. Keys are in the binders from the homework from last Friday. So make sure you check those. If you have any questions, I can just hold them over till tomorrow, and I can go through any that you need to. Or maybe one of you guys in first period, you're going to ask one of the questions that you have from sixth period. So stay tuned for that. But again, you should be pausing the video right now, going through these two problems, and then whenever they're ready, Mr. Kastenheiser, you can hit play again. All right, here we go. Factoring by GCF. Now, first off, what is it? What is a GCF? Somebody didn't hear tell me. What is a GCF? Greatest common factor. So for our purposes for these ones, again, I need us to write out what the GCF is. What is the GCF in this case, Nick? 5x. 5x. Good, it's 5x. We can intuitively see that 10, 25, and 5 are all divisible by 5, and that they all have an x in common. Now, what's the rule for the variables? You take the what power? Ooh, what do you... The lowest, right. You always take the lowest. Now, in this case, it's just an x to the first. But if I had raised this, if this was x to the 10th, x to the 9th, x to the 8th, right? That would be an x to the 8th as my lowest power. So just remember that. There were some of those on the GCF portion of the homework that I think was getting a couple people confused. So we got 5x here is my GCF. Now, remember, what do we do with the GCF? We put it on the outside, and then we divide it through. Now, beyond today, I am okay if you don't write the divided by. Everybody watching in sixth period, like this step, okay? I need you to write the 5x on the outside here. But in terms of dividing it out, I like to write it. You'll probably see me write it. But, you don't have to. I'm not going to force you beyond today. Okay, and then we actually divide it out. 10 divided by 5 is 2. X to the third divided by x is x squared. 25 divided by 5 is 5. X squared over x is x. Now, what do I have left over if I divide out the entire term? A 1. A 1, right. So minus 1 here in this case. Good, good. Questions about that one? We good there? Okay. Take a look at the next one. Factoring by grouping. Now, remember that I guess the first thing that we should look for is there a GCF out of the entire 4 terms? No. 3 and 2 are both prime, so they're relatively prime, so they're not going to have any GCF with them. All right, so if it's a 4-term polynomial, the only thing that we know how to do right now is factor by grouping. We underline the first 2 terms, and then we underline the last 2 terms, and then we factor. We factor by GCF. Okay, what's my GCF out of just my first 2 terms? Somebody raise their hand and tell me. What's my GCF? James? 3x to the second. Good. 3x to the second. 3x to the second here and here. Oops, 3x to the second. So that's going to leave us with an x plus 5. What's my GCF out of the second set of groupings? What's my GCF there? Carter? 2. Now, it's a positive 2, correct? That's why I'm going to write a plus 2 down here. Remember that if you'd be factoring out a negative, that plus would turn into a minus. But it's all positive. We're staying positive here. So with this one, it's going to be an x plus 5. Now, what do you notice? What do you notice?
Same polynomial.
The same binomial, right? The common binomial. The common binomial. We see this x plus 5, which is our first product. Then we put our leftovers. Now, what's left over after I remove the x plus 5? The 3x squared, and then the plus 2. Everybody follow me there? How did we do on those 2 problems? Do we do okay? All right, let's go over a couple from each set. Give me one or two to go over from the top. No, for everybody's sixth period, this is your homework from last night, so make sure you get that out. Go and take a look at first set problems 1 through 8. What questions do we need here? What do we want to go over? Okay, let's go over at least one or two. You guys pick them. Carter.
12.
From the first set, just 1 to 8.
The first section,
6.
Okay.
That's okay. Okay, here we go. Number 6 here. Looking here, 45d to the 5th, 9d to the 3rd. So my GCF, well, it looks like, think about, I always go this route. The smaller number is 9. What does 9 divide by? Well, 3 and 9, right? So take the biggest of the two numbers. Can I divide 45 by 9? Yes, I can. That's a 5. Yeah. So it's 9 is my GCF. And then the smaller power on D is d to the 3rd. So this is 9d to the 3rd. And then when I divide it out, that's a 5d to the 2nd plus, 1. Right? Because I factor out the entire term. Give me one more to go over from the top. Hudson? 8. Okay, so here, my smallest number is 8. Okay, can I divide 14 by 8? No. So what's the next biggest factor of 8? Well, 4. Can I divide 14 by 4? No. The next biggest factor of 8? 2. Can I divide 14 by 2? Yeah, 26. Yeah. So 2 is my GCF. So put it on the outside. Now, any letters for 8? No. So divide by 2 to each piece here. So this is a 13x squared plus 7x minus 4. All right. Moving on to the second set. Now, honestly, this 9, 10, 11, and 12, it's just kind of like getting you ready to factor by grouping, right? Don't these all have the common binomial setup that you see in factor by grouping? So all you really need to do is just look and see the common binomial, like take, for example, 10, the common binomial, which is x minus 8, and then look at the leftovers, the 13x, and then the minus 7. And that's my answer. Yeah. Oh. Sorry, folks. Everybody up there is kind of like, oh, Mr. Leverett. All right, let's go over at least one or two of these as well. Yeah. 13, love to. Let's go over 13. First thing to check is it in standard form? Yes. Okay. Now, let's factor by grouping, because I don't see a GCF out of the whole thing. Looks like I have an 8r squared as my GCF here. So 8r squared, 8r squared. That's going to leave me with an r minus 8. Now, is there a GCF between r and 8? What is it?
1.
Yeah, remember that everything could always be divided by 1 if we really needed to. So let's put a plus 1 here. Now, if I divide by 1, is it going to change anything? No, but we really didn't want it to change, because look at my common binomial. Didn't I want it to stay an r minus 8? So it's good that it was a positive 1. So now my common binomial is my r minus 8, and my leftover pieces are the 8r squared plus 1. All right, give me one more to go over from the bottom. One more to go over from the bottom. 18, thank you, Cole. All right, 18. So now, standard form, check. Let's see what my two GCFs are. Well, the first one here, 6 and 15. Can I divide 15 by 6? No. So the next biggest factor of 6 is 3. That'll work. 3h to the 2nd. Okay, so when we divide it out, that's going to be a 2h minus 5. Now, here's the tricky part about this one. What's the GCF out of the second set of groupings? Rocco? Be careful. Nope. Negative. Yeah. The tricky part here is the negative 4. Why a negative? Well, because it leads with a negative. Yeah. So negative 4 is my GCF, and now I put it as a minus 4 sitting right there. So 8 divided by 4 is 2. 20 divided by negative 4 is, I forgot my h, minus 5. And now we see the common binomial, don't you see? So the 2h minus 5, and then the 3h squared minus 4. Questions about that? Any other questions on the worksheet that we need to go over? Yeah.
You go to 15.
Love to. All right, standard form, check. Factor by grouping. Looks like I've got, now, is there any GCF with the numbers, the 3 and the 2? No, but they do have letters in common, right? The C squared. So that's going to leave me with a 3C minus 2. Look at my GCF of the second set. A 5, a positive 5, leaving me with a 3C minus 2. So the common binomial is the 3C minus 2. The leftover pieces are the C squared plus 5. Make sense? All right, let's take a look at the notes then for today. Now, how many terms did the factoring by grouping problems have? 4 terms, right? All of those factoring by grouping problems had 4 terms. What we are going to go through now is pretty much how to factor every other type of polynomial that we could possibly factor. Now that's going to take us the rest of this week. The quiz is going to be on Friday of this week. I haven't written that up on the board yet. But the quiz is going to be on Friday of this week. But on Friday we talked last Friday we talked about how to factor a 4-term polynomial. Today we're going to talk about how to factor a trinomial. How many terms does a trinomial have? 3 terms. You know, but here's the issue. We're actually going to spend a while on 3-term polynomials. Okay? We're gonna spend a while on factoring trinomials because there's different rules for how it looks. Okay? There's different rules for how it looks. Okay, now the first thing that I want you to do is to foil number 1 for me here. Foil number 1. Go ahead and do it real quick. Those of you watching along 6th period, you do this as well. Foil number 1. What do I mean when I say foil? First, outer, inner, last. Distribute, right? Multiply it together. Because again, the goal of factoring is to unmultiply, right? To factor means to reverse the process of multiplication. So really, if I have x plus 4 times x plus 2, my goal for factoring is to reverse this process. And I see most of you are already done here. X times x is x squared. X times 2 is 2x. 4 times x is 4x. 4 times 2 is 8. Okay. X squared, 6x plus 8. Now, I got to be honest. When I was grading those past quizzes, we were very good at multiplying that stuff. Like we did really, really good at that as a group in general. Now, our goal for this section is to be able to take a rule that starts with this and ends with this. Again, we're reversing the order here. We're going from this trinomial and turning it into 2 binomials. Now, what do you notice about these 2 numbers and how they relate to the trinomial down here? What do we notice about those 2 numbers and how they relate to the trinomial? Look at the 4 and the 2. How do they relate to 8? They multiply factors of 8, correct? So these 2 numbers, the 4 and the 2, are factors of my last number. Now, what do we notice about 4 and 2 as they relate to 6? Don't think of factors anymore. What do we do to 4 and 2 to get to 6? You add them together. So what we are going to be looking for to go from here to here, from the x squared plus 6x plus 8 to the x plus 4x plus 2, is we're going to be looking at that last number. That last number is going to be how we identify the 2 factors. And then we look at the middle number and we say, okay, well, they have to add up to be the middle number. Factors of your last number that add up to be the middle number. Let's check that process to see if that's going to happen again. I'm going to foil this real quick. X squared minus 3x plus 6x minus 18. Okay, combine like terms in the middle. That's going to give me an x squared plus 3x minus 18. Look at 6 and negative 3. Don't we multiply them to get to negative 18? Don't we add them to get to positive 3, taking into account the sign? 6 plus negative 3, didn't that get us positive 3? So that's what we're going to be looking for. Things that multiply to get you your last number and add to get to the middle number. That's how to get those two numbers and those two factors. Okay, so let me ask you, what two quantities could multiply together to give us x squared plus 6x plus 8? Well, oh, that's my same exact two problems. Let's jump back down to number 1. Let's just do straight to here. Sixth period, just jump past that first part, that second part there. All right, x squared plus 7x plus 12. So here's the process that I'm going to be taking you through. I want you to list out the factors of your last term. What is my last term in this case? 12. So let's list out the factors of 12. Okay, this might be overkill, but let's list them all out. 1 times 12. 2 times 6. 3 times 4. Those are all the factors of 12, correct? Now, if I add those together, what is 1 plus 12? What is 2 plus 6? And what is 3 plus 4? Okay, so which set of factors add together to get the middle number? 3 times 4. These ones here. So what does that imply? Well, that implies that my answer is x plus 3, x plus 4. You look for the factors of your last number that will add together to get the middle number. Now, how would I check that answer? How could I check that answer? Rocco? Foil it, right? I could foil it back together, and I could see that x squared, 4x, 3x, 12. And look at that, x squared plus 7x plus 12. That does get me back to my original problem. Do you see that? So that's what we're going to be looking for. Factors of your last number that add to get to the middle term. Okay. Take a look at number 2 here. Let's list out the factors of 18. Okay, factors of 18. 1 times 18. 2 times 9. 3 times 6. Let's figure out their sums. Those are all the factors of 18, correct? Let's figure out their sum. 1 plus 18 is 19. 2 plus 9 is 11. 3 plus 6 is 9. What's my middle term? What's my middle term? Be careful. Negative 11. Are any of these sums negative 11? Can I make them negative 11? Or, yeah, well, both of them negative. Look at that. Because what is negative 2 times negative 9? Hold on. What is negative 2 times negative 9? Still a positive 18, correct? Did I change the product at all? No, it's still positive 18. We're still good with that. What is negative 2 plus negative 9? Negative 11. So what we can say here, well, this one is just an x minus 2, x minus 9. So if you need to make the factors negative, you can just make them both negative if you needed to. Let's take a look at the next one. Now you got to fill these in. Here's 3. Go ahead and fill that in. I have x squared plus 5x minus 24. X squared plus 5x minus 24. So I find the factors of, look at that, negative 24. So this is the first time we're finding factors of a negative number. When you find the factors of a negative number, it's not more difficult, just your list gets a little bit bigger. Because I could say negative 1 times 24, negative 2 times 12, negative 3 times 8, negative 4 times 6. But here's my issue. Can't I go now and take each one of these factor pairs and flip the negative? So I really could now say negative 6 times 4, negative 8 times 3, negative 12 times 2, negative 24 times 1. See, factoring a negative at the end makes our life just a little bit more difficult. Let's find the sums. Well, this would be a 23. This would be a 10. This would be a 5. This would be a positive 2. This would be a negative 2, negative 5, negative 10, and negative 23. Which set of factors work? Negative 8. Nope. Negative, not negative 8 times 3. Negative 3 times 8. That's the only set of factors that will work. Because I want to get a positive 5, not a negative 5, but a positive 5. So x minus 3, x plus 8. Don't believe it? Foil it back out. I always think of factoring trinomials kind of like a puzzle. You just got to find which puzzle piece fits. Okay, let's take a look at number 4 here. Factors of negative 30 that add together to get negative 7. Okay, factors of 30. Negative 1 times 30. Negative 2 times 15. Negative 3 times 10. Negative 5 times 6. And then I could loop that back around again with the opposite factors, negative. Negative 6 and 5. Negative 10 and 3. Negative 15 and 2. Negative 30 and 1. And now we list out our sums. 29, 13, 7, 1, negative 1, negative 7, negative 13, negative 29. Which set of factors wins? Which set of factors are going to work? Rocco? Yeah. Because this set of factors gets me the negative 7 that I wanted in the middle. Right? There's only one set of factors that had to get to the middle. All right, so that means that's an x minus 10, x plus 3. Now, you may be thinking, Mr. Laverick, I was able to see that without needing to list out all of my factors. Like I knew once I knew I wanted to get negative 7. I could have stopped that list earlier. Do I really need to do all of this work in the table here? The answer is no. I don't want you to have to list all of the factors out. I want you to think intuitively about these things. I want you to already know which factors are going to work without needing to write out the entire list. However, there are going to be some of you that are going to say, oh, that's prime, when it's not, and you haven't listed out all of your factors. If you're going to call it prime, you better have listed out all factors, okay? Because if you get this whole list and none of them is the sum of the middle, then you can say prime. Okay, but you have to be careful when you say prime. All right, flip it over onto the back. Flip it over onto the back. Okay, what am I going to find the factors? So now this is how I will do these problems from here on out. Those big tables on the front, I'm not doing that anymore. You can if you need to fall back on it. What am I going to find the factors of in this case? 4. Which set of factors of 4 add together to be 5? 1 and 4. Do we all see that? So all I'm going to say is 1 times 4. Perfect. That's enough work to show. X plus 1, X plus 4. Done. You see that? That's what I would love to see in the end. Write out your last number, write out the factors underneath it, put it as 2 binomials. Let's take a look at the next one. X squared minus 5x plus 6. What am I going to find the factors of? 6. Now be careful here. What do they need to add together to be? -5. Be careful. What are my 2 factors that will work for this situation? Andrew?
-2, -3.
Good. -2 times -3. Do not say -6 times 1. -6 times 1 does not work. Why? Well, because what is -6 times 1? -6, not +6. You're right, -6 plus 1 would get to -5, but that's not in my list of factors, right? My only list of factors gets me a +6. So be careful there. X minus 2, X minus 3. And if you had said incorrectly that it was, come on, red, please. If you had said incorrectly that it was -6, +1, look what would happen when you FOIL it together. X squared minus 6x, first outer, oops, I forgot my outer, plus 1x minus 6. You would say x squared minus 5x, oh shoot, minus 6. What did I want in the beginning? Plus 6. See, you would have seen it here and gone, oops, that's not right. Go back, correct it. Let's take a look at the next 2. Go ahead and write those in for us here. What number am I going to find the factors of in number 7? -20. Factors of -20 that add together to get 1. 1. What are they? What are you raising your hand to tell me? Factors of -20 that add together to get 1. Now, this is a tricky one. No pun intended. This is a tricky one. So if you need to write out your list, you can. -1 times 20. What's the sum there? 19. It's going to work. -2 times 10. What's the sum there? 8. That's not going to work. -4 times, oh, bingo. What's the sum there? What's the sum? 1. Is that going to work? That's exactly what we wanted in the middle. So we say x minus 4, x plus 5. See, do you see how I can work my list until I find what I need? You don't have to write out the entire list. Take a look at number 8. Factors of -8 that add to get to -7. What are they? Factors of -8 that add to get to -7. -8, +1. Very good. -8, +1. So it's x minus 8, x plus 1. Those of you who are really good at your math facts are going to crush this section. Those of you that struggle with your math facts, you better have a calculator right by your side. Because if you don't know your factors, oof, life's going to be rough this section. Okay, so in summary, here in the end, there's some patterns that we can see. There are some patterns that we can see. If your C value is positive and your B value is positive, if both of those things are positive, these are both positive as well. There's some patterns that we can see. If those operations are both plus signs, then these are going to be both plus signs. If this one is positive and this one is negative, then you get one of each. Oh, I'm sorry, not one of each. They're both negative, excuse me. They're both negative. If the last term is positive and B is negative, they're both negative. If this is negative and this is positive, you get one of each. Order doesn't matter there. You're just looking at the numbers at that point. And the same thing is true that if this is negative, you get one of each. So here's the moral of the story. If this last sign is negative, you get one of each every single time. If that last sign is negative, you get one of each every single time. One's negative, one's positive. If this last sign is positive, they're both the same. They're both either plus signs or minus signs. What tells you what they are? The first sign. So this is going to be the same sign. Both of them are going to be positive. This is going to be the same sign. Both of them are going to be negative. Okay? Now, those are just shortcuts. Those are just ways to check it. Are you still going to do the factors with the sums? Of course you are. Yeah, of course you are. And that flow chart just kind of summarizes things. So this is for my sixth period class. Your homework is page 395. You can use the rest of the time to work on it. Sixth period also, I already told first period this. Also, there's a new edge elastic up online. I have already assigned it to you. The edge elastic completion has been awful. Do your edge elastics. Okay. All right. Any questions before we conclude? No. Thank you, Mr. Castanizer. Shout out, Mr. Castanizer. Thanks for covering for me. All right, I'm out.